And this is a variant of a talk where I gave in Japan where I met Ray recently, or re-met Ray recently. But it's sort of explaining how spectrum policy and innovation are related to each other. So this is not to convince you that you should spend the rest of your life in spectrum policy, but to convince you that there are spectrum policy issues you should think about as you do research in other aspects of wireless. Okay. First thing, telecom is a big industry in its own right. Basically, in the U.S., grossing in the order of 10 to the 8th dollars a year. Basically, cellular, wireline, and broadcasting are each around 10 to the 8th dollars a year. And telecom is becoming more wireless, but telecom is also a basic commodity in today's economies. And here's a quote from the European Commission. ICT, Information Communication Technology, European speak for this stuff, we don't use that phrase here, contributes macroeconomically to productivity growth and competitiveness. So it's not the issue looking at telecom from the policy issue is not that telecom has a lot of jobs. A lot of people do work for Nokia, a lot of people work for T-Mobile and Verizon, but the importance, economic importance of telecom is not just the number of people who work for those companies, it's the fact when those companies do their job well, it makes the whole economy in country X more efficient and contributes to economic growth and competitiveness. Because frankly, you know, there are countries in the world that have lower hourly wages than the US and Europe does, and they're not going to compete in the long term with certain other countries that have low hourly wages unless their economies are efficient. And that's why telecom is important. And as I was mentioning briefly before Ray got in the room, FedEx, Travelocity, eBay are companies which are not telecommunications companies, but they're companies whose very existence was created because of new telecommunications. So efficient telecommunications creates jobs at T-Mobile and Nokia, but also creates jobs at these companies, and then these companies in turn make other companies more efficient. The whole U.S. economy is more efficient because FedEx exists. FedEx would not have existed without new telecommunications. And lest you think this is only an issue for industrialized societies, there's a Washington Post article I referenced there that talks about fishermen in rural India whose household income went up because they got cell phones. And before they went out each day fishing, they had access to market information of the market prices of different types of fish, and they could choose how to spend their time based upon up-to-date market information. So telecommunications not only helps make FedEx more efficient, even in less industrialized nations, adequate telecommunications increases everybody's income and the value of society. Okay, let's look at historical growth in wireless capacity. Now, Marty Cooper, who is legendary as the inventor of the first handheld cell phone, that's the first handheld cell phone I remember using one of those before they became publicly available, made an interesting comment in IEEE Communications magazine about sort of his version of Moore's Law. The communications capacity has doubled every 30 months over 104 years. And if you believe that, then you have an increase of 10 to the 13th over 104 years. And that will be right. I mean, originally Marconi only had one transmitter, and it was probably sending Morse code at 5 words per minute. How much wireless stuff is spent today compared to that? But this is the type of growth that we've had in the wireless industry, and we should all be proud of it. Now, where did that come from? In the case of cellular, here's another article that gives some examples of how much cellular has improved. But cellular isn't. There's more spectrum available. We've divided spectrum into smaller pieces. Modulation has only accounted for a factor of 5, but that's helpful. But reduced cell size is probably a factor of 1,600. But we need more and more wireless capacity. We've achieved it in a variety of ways. There are some fundamental limits like Moore's Law, but we're approaching the limits of them, so we have to keep thinking of new ways to grow wireless capacity. We're basically using all the spectrum which is appropriate for mobile communications is already in use, so there are no green fields out there. Okay. So some of the issues talk about wireless regulations and standards. So they promote innovation or hinder it. And I'll particularly give the examples of Wi-Fi and GSM. There's no simple answer. There are people and cases that say standards are good, and there are people who say standards are bad. And if someone tells you one extreme or the other, don't believe them. There is no simple answer. National viewpoints are often tied to national cultural systems and also to national legal systems. As we'll see, there are different types of legal frameworks in different parts of the world. We may not agree on these things, but at least I'm hoping we'll understand what some of the issues are there. Oh, and understanding will help select the best policy for specific cases. Okay. This was a very good article in Spectrum in September by a fellow who has an engineering degree and is a Washington lawyer. Radio's regulatory roadblocks. I would urge you to look at that article. If you don't have Spectrum, there's a website for it. Also, FCC in August issued a notice of inquiry, essentially asking for information on how to speed up wireless innovation. This FCC document plus the 5860 documents people have sent FCC in response are also fascinating in my view of what are the problems of regulation innovation. But if you don't have time to listen to me remember, think about this one slide. It is an old area. Think about this one slide. This is the most important slide in the whole thing. Regulation, for better or for worse, is very important in wireless. Okay. Here are the regulations. Here in the ITU regulations, the ITU radio regulations, and the FCC regulations. If you're building wireless technology, spending your career in wireless technology, the one thing you should remember, if you forget everything else I say today, is they're just as important as Maxwell's equations. Now, I happen to be a differential fan of Maxwell. How many of you favor differential, and how many favor integral? So differential? The rest of you are integral fans? Okay, I prefer differential. But anyway, if you're designing systems for the real world, you've got to consider the Maxwell's equations and you've got to consider regulations. Now the difference is Maxwell's equations has letter C in them, right? C? Okay. C isn't going to change. You know, you ain't going to design a radio system that signals go any faster than C. That's the limit. Those regulations do change, but those regulations, as you learn in control theory, have feedback in them in time constants, and the time constants are typically a couple years. So if you have a problem and those have to change, you better just realize that it takes a couple years to change them. So the sooner you identify those problems, the sooner the system works. But if you remember nothing else, please remember this PowerPoint. Okay. Why is wireless different than other technologies? You know, if you want to make new integrated circuits for PCs, you don't have to worry about regulation. Okay. The basic concepts of spectrum management were formed in the aftermath of the Titanic sinking. Okay. When people tried to reconstruct why the Titanic sank, part of the problems, or why so many people died, was the radio systems weren't really well regulated. And many of the concepts that came in at that time, the maximum usable frequency was probably 100 kilohertz. Many of the concepts that were appropriate then aren't appropriate now. National spectrum regulators often attempt economic planning. That is, people who built 3G started working on it 20 years ago because they said, this is what we need 20 years in the future. This is what most people call Soviet economic planning. But that's the way it's really done in the inner circles of the ITU. People are projecting 20 years ahead what's needed, projecting demands and allocating resources, and everyone 3G is happy what they did. Does anyone remember ISDN? ISDN, you know, information services people don't need. Okay. The same basic people at the ITU in Geneva who thought of 3G also said in the early 80s, everybody's going to need ISDN technology in their home. Well, does anyone here have ISDN in their home? No. There is a problem there, and that's one of the same ITU that gave you 3G also gave you ISDN. Regulators in each country generally give little attention to entrepreneurs, little attention to disruptive technology. Indeed, it's a bad name in regulatory circles, and niche applications. But Wi-Fi started as a niche applications. The people starting working on Wi-Fi, one of their highest concerns was wireless data links for cash registers in supermarkets, a real niche applications. And if they had gone to the ITU with that, they would have just laughed them out of the room, because they're interested in killer apps, not niche applications. Okay, let me give you a different example. Here are two must-have products, the iPod and the iPhone. Which one came first? Why? That iPhone is subject to wireless regulation. That iPod isn't. You don't have to ask the Federal iPod Commission, Federal iPod Commission, may I build an iPod? You don't. Even though the iPhone had relatively simple regulatory issues, the fact of life is new technologies for non-wireless things come in faster than they come in wireless because of regulation. Here's an interesting, has anyone heard of iTrip? Does anyone have an iTrip? It's an obscure niche application. iTrip is an iPod attachment that you plug into the connector on your iPod, and it's a low-power FM transmitter, so you can hold it next to a clock radio or car radio. It's a simple way of doing that. It sells for $20, just plugs into any iPod, and it transmits like that. FCC has allowed this class of systems for decades. No one at FCC can remember when they were first allowed. You can basically, in the US, sell low-power FM transmitters of a few milliwatts for any use you want. The usual use prior to this was wireless microphones for karaoke parties. But the rules are very general, and the guy who made iTrip was taking advantage of them. But in Europe, they were forbidden. Verboten. All throughout all of Europe, you could not sell an iTrip because they had very specific rules. This spectrum can be used for this spectrum can be used for that, and none of them possibly covered iTrip. And indeed, here is a 2006 decision from the UK, finally allowing iTrip in England, and a few years later, most of the rest of Europe followed. But you don't get innovation in wireless technology if you have to go on your hands and knees and beg for it. And so it's no accident that the maker of iTrip was a US company. And for more complicated reasons, it's no accident that Qualcomm is a US company too. Because if Andy Viterbi, the founder of Qualcomm, had never emigrated from the US and had stayed in Italy, I am positive he would be an obscure retired professor, no doubt with brilliant journal articles to his credit, but there would be no CDMA use in commercial communications anywhere in this world. Because only when the fertile mind of Andy Viterbi met the regulatory environment of the US did CDMA become a commercial product. Okay. In the case of iTrip, barriers exist for wireless, just doesn't exist for exotic technologies, particularly exotic technologies with complex interference issues such as spread spectrum or ultra-wideband or power line carriers, which is basically RF over medium voltage power lines that raises a bunch of issues here. Most countries have prescriptive spectrum policies, that is, you may use technology 1, 2, and 3, and by definition, nothing else. Creates barriers to innovation, even minor innovations, even something as simple as the iTrip in most countries would be forbidden. Okay. And the role of spectrum policy, some people say, is pinning the lines on the information highway. That's the paint truck. Prioritizing use of spectrum, controlling interference, facilitating new technologies, but in some countries, spectrum policy is also used for industrial policy to gain trade advantages. So, for example, until 3G, Japan had very different cellular systems than the rest of the world, which was probably to keep Nokia from selling cell phones in Japan. Okay. Also, sometimes spectrum policy is picking technological winners and losers. the US, President Reagan said, do not pick winners and losers. And so it's been an obsession of the US government not picking winners and losers since Reagan. But in other countries, the Europeans picked GSM as a winner, and to this day, you can't use a cell phone other than GSM in Europe in those bands. Not only keep something other than GSM, every nuance of the GSM standard cannot be changed without blessing from the GSM bureaucracy in southern France. Yeah. That doesn't exactly encourage innovation. Now, standards standards have some good points. They help ensure interoperability. If you have a 3G phone, you can take it to Europe or Japan, it works. That's not bad. It has some downsides too. It can help competition or it can hurt it. And some national spectrum regulators use standards as the gatekeeper here? The gatekeeper to spectrum access. And for example, in Europe, Ieee, the group in southern France, or in Japan, Ieee, the standards group in Japan, have quasi-governmental roles. If you ask them, they'll say, well, we're not the government. But the reality is, everybody knows that Ieee and Ieee are very, very close to the governments that created them. In the US, FCC rarely requires standards for wireless systems, but defers to the marketplace. And whose picture is on the 20-pound note? Anybody ever taken economics course? Adam Smith. Adam Smith, the invisible hand. Okay. In the US, the invisible hand of Adam Smith picks. If you don't know what I mean, please Google invisible hand. It's the invisible hand of the marketplace, picks most most technical standards. The few exceptions have been digital television, where the FCC prescribed a standard, and the first generation cellular, but not the second or third generation cellular. Okay. Types of standards. Okay. We have, in the world, we have several different types of standards. We have standards that are governmental or quasi-governmental. For example, the GSM standard is one of them, and IMT 2000, which is another way of looking at 3G, is a standard which has essentially been adopted by governments. In Europe, you may only use GSM. You can only use GSM standard that's been blessed by Ieee. If your name is T-Mobile, you can't change that GSM standard if you don't want to offer a new service unless Ieee approves that change. Okay? Another type of standards we have are voluntary open standards. Okay. IEEE 802, the people who brought you Wi-Fi, is a voluntary group. Anyone who pays their $10 a year membership in the IEEE Standards Association can get involved in IEEE 802, can go to all their meetings, and once you've met a minimum number of meetings you've attended, you can vote just as much as Motorola can vote. That's what open standards is. Anyone can come. They have to get like 80% majority to approve something, and what's going on is transparent. TIA, Telecommunications Industry Association, is similarly an open association, best known for microwave type standards, not cell phones. Okay. We also have, interestingly, voluntary closed standards. These are not done by governments, but you have to be invited to come. So, for example, the original Bluetooth standard, not today's Bluetooth standards is part of 802, but Bluetooth started as a group of people who were invited by Ericsson to get together and say, let's design a Bluetooth named after a Swedish king, Ericsson, a little nationalism there. But only people who were invited could come, and they developed a standard. HomePlug, which is a local area net for homes and uses power lines, was that way. CDG, the CDMA systems used for second generation cellular are controlled by CDG. They're not controlled by ITU, they're not controlled by FCC. This is a voluntary standards group, but it's a closed group. You can't go to meetings, you can't vote, that's the way it is. You know, sometimes that's the right way to go. Let's talk briefly about different countries. In the UK, the telecommunication regulators for the past 5 years is a group called Ofcom. Like the FCC in the United States, it controls spectrum, broadcasting, and telecom. It does not pay for R&D. And one of my pet hang-ups is when regulators pay for R&D, they confuse their roles because anything you pay for the development of, you want to be successful, and there are ways regulators can make things successful. I happen to think that's a bad idea. I've spent a lot of time in Japan. What's called in English the Ministry of Internal Affairs and Communications, and those of you who speak Asian languages will see that the Japanese name isn't the same, but that's what the English translation is. Like the FCC controls spectrum, broadcasting, telecom, it does pay for research. In Japan, there's a $5 a year fee on every cell phone. There are 100 million cell phones in Japan. That's a lot of money. And that goes into R&D and a bunch of other things. That's a bad idea, in my opinion. In Canada, we have two organizations. I happen to admire the Canadian system, by the way. The group called Industry Canada is a non-political cabinet agency that is only the Minister of Industry Canada's politician. There are no other political people in Industry Canada except for the Minister. They control spectrum policy, all radio licensing except broadcasting, and technical telecom issues. They do pay for R&D. The Canadian Radio, Television and Telecommunications Commission, normally called CRTC, is a small agency chock full of politicians. Like the FCC, it's a commission, a bunch of commissioners who are appointed by politicians. It deals with the issues of broadcast ownership and content, telecom ownership and pricing. These are very political issues. And what I like about the Canadians is they took the political issues and they put them in a political agency, and they put the technical issues and put them in a technocratic agency. I happen to like that. It's never going to change in the U.S., but it's interesting to note that. In the U.S., we have two agencies also. My alma mater, the Federal Communications Agency, that deals with spectrum use by everyone except the federal government. Telecom, broadcasting, it does not pay for R&D. There is a more obscure agency, the National Telecommunication Information Administration, NTIA, whose jurisdiction is federal spectrum use. That becomes nightmarish having two agencies on spectrum use. But that was a decision that was made 70 years ago and it's not going to change. Okay, let's talk briefly about legal systems without going into how the world is run. There are basically two legal systems in the world. The blue legal system is a civil law system which derives from the Napoleonic Code. The reddish countries here derive from the Magna Carta and British common law. Very interesting, if you look at GSM versus CDMA, there's a lot of correlation. And there's probably a reason for that. And there we have Napoleon, there we have the Magna Carta. Civil law goes back to Roman origin, but basically assumes that the government should have a proactive role in deciding how society does things. The Magna Carta of 1215 tends to have a view that government should not be proactive, private society should be able to do things. These follow through in spectrum policy. Saint-Exupéry, The Petit Prince, The Little Prince, favorite children's book. There's a great quote in there. The Little Prince says, "As for the future, your task is not to foresee it, but to enable it." So one of the key issues in spectrum policy is not should you read The Little Prince, but that quote is a great quote. Because some people think that the spectrum policy wonks, people like me, should spend their time foreseeing the future. Other people think the spectrum policy wonks should spend their time enabling the future. I happen to think that enabling is the right thing to do, but if you ask most people, they'll say, no, foreseeing is what we should do. Okay. Here are Wi-Fi and GSM, and here is historical data on their growth. So they both have hundreds of millions of users. They both grew very quickly over time. Where did they come from? They came from very different origins. They changed our world. One came from a very traditional origin in which, like Soviet-style planning, people said, this is what we need, this is how we should do it. And one is based upon deregulation, more like what I said about the common law systems. Government should enable people to do things, not tell them what to do. Some devices have both GSM and Wi-Fi. Not many, but you know, if you have an iPhone 3G, it turns out it has both. Okay, where did Wi-Fi come from? there, up in the upper right-hand corner, is the program of a conference that was in 1991 in Quebec. And it's interesting, potential commercial applications, myth or reality. In 1991, people were actually having a whole conference, a 3-day meeting, of does spread spectrum really have commercial uses? A lot of us now have CDMA cell phones. I don't know if you've ever thought about this, but all the 3G systems in the world are CDMA based. Europeans don't like to say that, but look at take an IMT 2000 phone apart. But just look at the waveform. It's CDMA is an integral part of it. But in 1991, this was a big controversy. And if you go back and read the technical articles from the 80s, you can see there were even more controversies of people knew about CDMA, but was it practical for anything? It was a hot and heavy debate in technical journal articles in the 80s. And I believe that in that environment, it was unlike the Etsy, Ieee, the TIA, who developed standards by consensus. People sit in a room, they're nice people, they're good techies, they talk to each other and have to reach 80% consensus. That it was impossible for anyone in the 80s or early 90s to ever agree upon spread spectrum CDMA for any application under the sun. And if you don't believe me, go look at the literature from that time period. Niche applications like wireless, who needs a wireless cash register? Yeah, put yourself in 1990. Does anyone need a wireless cash register? Would have attracted no interest in mainstream standards organizations or warehouse scanners. Some of the 802.11 people were trying to build optical scanners for warehouses. So you go down to a warehouse and scan barcodes on boxes. And this is a niche. Who wants it? Okay. A little bit of political history. That's President Carter, that's President Reagan. Alfred Kahn is an academic. See, academics do something useful. He was a Cornell professor, former chairman of the New York Public Facilities Commission, and he advocated a theory that deregulation was key to economic growth. And under the Carter administration, he had an amazing influence, and FCC Chairman Ferris particularly said, this is what we're going to do in communications. We are going to get the government off the back of the people. And when President Reagan came in, this was one of the few things that Reagan and Carter both agreed upon. The government should not regulate people as much. You didn't think anyone could talk here with a picture of Ronald Reagan, did you? Okay. A brief timeline there is, in '79, spread spectrum was identified as a deregulatory goal. I got a job at FCC. FCC started asking questions formally in '81. The basic rules for Wi-Fi and Bluetooth were adopted in '85. You can see what I looked like with a little more hair in 1985. And yet, interestingly, here is an issue of IEEE Communications magazine from that period, and it talks about, it's an issue devoted to spread spectrum. And what's it talking about? It's talking about military use and jamming. Whole special issue of military. People at that time period talked about spread spectrum only in the military context. This is so '85 was a basic decision. The first commercial spread spectrum hardware. This is not Wi-Fi, but it's functionally comparable to Wi-Fi, lower data rates, things like that. But it was a local area network. It was the first commercial system sold. It hit the market in '88. Wi-Fi deliberations began in 1990. That's Vic Hayes, who was the first founding father of 802.11 and ran 802.11 for several years. And yet the next year we had this conference, Myth or Reality. Okay. First Wi-Fi standard came in '97, and then the rest is history. This is not government saying this is what you must do. This is government getting out of the way. Okay. I love this unexpected uses of Wi-Fi. Municipal Wi-Fi, in many cities you walk around and you can use Wi-Fi anywhere. We weren't thinking about that at the time. This is a bathtub with a Wi-Fi iPod music link. Who would have thought it, right? It has underwater speakers. And why does it use Wi-Fi? Well, in bathtubs and swimming pools, we have big electrical safety problems. because the music comes over a wireless link, it solves the safety problems. Fiber could have been used, but this was certainly easier than fiber. But if you want to buy an expensive bathtub for your home, you can get one with the underwater speakers connected to your iPod. Who would have thought of it? And our local supermarket has this handheld scanner that as you fill up your shopping cart, you scan things, and when you get to the checkout, do they have that in this area? And you get to the cash register, you just give the cashier your handheld scanner, and they immediately download the prices of everything you bought. You know, if you went to the ITU and said, I need a new technology for handheld scanning in supermarkets, they certainly would have treated you like crazy. And here's a picture of a handsome guy at a marina in France, and on this ramp going down to the dock that looks like a Wi-Fi symbol. Yep. Most marinas in the U.S. and Europe now have Wi-Fi, so you can sit at your boat at the dock and do your thing. If you would ask the FCC or ITU for that, they would have said you're crazy too. Okay, let's look at where did GSM come from? The original cell phone systems in Europe, each country came up with their own first-generation cell phone standard, and it was sort of a Tower of Babel. So the Scandinavian telecom operator and the Dutch PTT proposed CEPT. CEPT is a European group which is the regulators of Europe. It's a French abbreviation, but it's the spectrum regulators of Europe working group. And they proposed that there be a common 2G standard. And the GSM committee, the GSM committee stood for group. So it was a committee. GSM originally was the name of a committee. It was formed by CEPT in '82. The European Commission decided to set a band aside in '86 for a common European standard. The key technical parameters were chosen in '87 under this. CEPT is a governmental group. The members of CEPT are the national regulators of the European countries. Companies don't belong. This is national regulators too. And the ETSI standard for the original GSM standard came in '89. The first hardware came in '91. Now I have to realize, at this point, this is the only technology that can be used in Europe in only one band. So there was the people who developed this first hardware had zero risk because no one could compete with them. It's a lot. Think of the problems Qualcomm had developing its technology because it wasn't sure anyone would want to buy it. But in Europe at that point, if you wanted to build cell phone systems in Europe, you had to build that because nothing else can be sold. And they reached 1 billion customers by 1998. So that's where they got their growth from. And indeed, if you look at the world today, the blue parts of the world are the parts that have, the blue-green are the parts that have GSM, and the yellowish parts are the part that has the 3G version of GSM. So GSM really does cover most of the world that has any population. This big country over here doesn't seem to have much GSM except in the coastal areas, but in most of the rest of the world, GSM has penetrated reasonably well. Amazon doesn't have it either, but China and Russia are the notable places where GSM has not taken over the whole world. Okay, now let's look at traditional spectrum policy versus deregulation. With traditional spectrum policy, interoperability is not a problem. If you take your GSM to Europe, it's going to work. Minimizes investment risk. The people who developed those first GSM systems didn't have to worry that Qualcomm might compete with them because they couldn't. Maximizes manufacturing competition. So if Ericsson and Nokia were both making GSM equipment, they could compete on different implementations. It would have to be common air interface, but if they could compete on certain aspects of design, but not other aspects. The downsides is little interest in niche applications. Disruptive innovation is viewed as a disadvantage. So you will evolve very slowly. That's why CDMA was never selected for any second generation systems outside the US, because it was disruptive innovation. And this type of process, they don't like disruptive innovation. It's also very time consuming. The pros and cons of deregulation is innovation and disruptive technology handled well, responds to niche applications that could become big ones. A lot of niche applications stay niche applications. But it creates real investment risk. When Qualcomm went to raise money to do its original manufacturing, it clearly had a harder time justifying investors spending money on a CDMA production line than Ericsson did on trying to get money to start a DSM production line. And it raises interoperability issues, and indeed, while that's not a problem in the US now, certainly in the early 90s, there was an issue of would the US become half CDMA, half TDMA. As it turns out, it did, but that was a real concern at that time. If you want to know more about this, here is a great book by some British friends of mine on the avant-garde view of spectrum policy, not the traditional view, the avant-garde view. And if you order it from my website, it's a $2 commission, but you can order it. If you want to order it yourself, feel free, but you can order it from my website. So here I have suggestions for high payoff policy-related research. So if you had all the money in the world and think you know where to get money, here are some ideas I have on some research things. One is in spectrum policy, the key issue is does new technology A cause harmful interference to existing users? What is harmful interference? Now, if you go to my website, you'll find my blog. I talk about this in my blog all the time. There is a term called harmful interference that the ITU defined in the 30s. And the definition maybe was appropriate for the 30s, but what it means now is debatable. And it would be nice to come up with a better either definition, a description. What is interference between two systems, and when does it pass a limit where it's not acceptable? Whether you define a limit or just come up with a yardstick, this is a key issue for facilitating the introduction of new technologies. And I would urge the technical community to get more involved in how can we define or measure harmful interference. Okay. Number two, a lot of people in the cognitive radio business say, let's design a cognitive radio. There are other radios out there today. We'll design a radio to find holes the spectrum is not used. Sometimes that's a good idea, particularly in TV white space where broadcasters are on the air 24 hours a day and transmit from high antennas. That's a good idea. But other times it isn't, and particularly if you're sharing spectrum with public safety users who just the thought of interference gives them nightmares. And public safety users also tend to have connections with the regulators, and as a result you end up with very, very conservative decisions. And if you go to my blog, source all information, there's a 5 gigahertz sharing system worldwide now, so dynamic frequencies, DFS, dynamic frequency selection, of how you can listen for government radars at 5 gigahertz, and if you find the hole, you can transmit. Read the standard very, very carefully, and you will see that in that standard, there's a requirement that if for 1 microsecond you hear more than minus umpty-ump dBm, for 1 microsecond, you have to declare that channel occupied, and how soon can you come back? Who's done it? Anyone know how soon you can come back? If you hear for 1 microsecond, how you can review whether the channel's available? 30 minutes. So any noise spike of 1 microsecond, whether it came from a vacuum cleaner or a drill, you got to rule that out for 30 minutes. Yeah. Basically, this is such a conservative standard. There will be no interference. There's also going to be very little spectrum. And in TV white space, it's the same thing. So for my Gsm paper for this coming spring, and I'd be glad to share copies with you, what I have suggested in the Gsm paper is, Gsm is a major cognitive radio conference, that instead of just looking at how we can design cognitive systems to exist with today's spectrum users, how can we design future systems for public safety systems such that they're easy to share with. And if instead of passively listening, is the public safety guy there, isn't he there, is he there, isn't he there, maybe there can be some interaction. And I think you'll find, because public safety systems of necessity have very high peaks and very low average. Big peak to average ratio in public safety communication systems. Think of a fire department. When there's no fire, they're not using the spectrum. Okay. Public safety uses up a huge amount of spectrum in every country, has these high peak to average ratios. Sharing with them with classic cognitive radio is a losing proposition, because the rules will always be written so much to favor the public safety people, you won't have much spectrum. Maybe instead of independently designing the cognitive system, you should be thinking about the next generation of systems and how they could be designed to work together. Topic number 2. Topic number 3. In the real world, the rollout of new wireless technologies is severely impacted by not a technical issue, not a legal issue that we've been talking about, it's local zoning. People don't like cell phone base stations. Now let's think about this. Both the cell phones industry is infamous for building base stations everywhere in suburbia. This is mainly a suburban problem, by the way. It's not a problem in central cities, because in central cities you put antennas on the side of buildings and they disappear if you're a little bit careful. It's not a problem in rural areas because people don't live next to base station antennas in rural areas. It's a suburban problem. And not only cell systems, but most wireless systems are going to a cellular-like architecture in the next decade. And I like to toss out a number that you need 25 independent radiating systems per square mile in suburbia in the next 10 years. A radiating system is like one level of cell tower. Look at it, a typical tower has 3 to 6 levels stacked on top of each other. You're going to need the equivalent of 25 levels in the next decade. Is that the right number? I don't know. But if you don't like that number, come up with your own number, but I think that's about the right number. Could be higher. And the current design concepts where you put a stick up and you put a platform on it, and then each person builds their own ugly thing on a platform. So the combination of all these platforms is as ugly as you can make it. And you may have heard the phrase, it looks like it was designed by an engineer. Most cell towers in this country look like they're designed by an engineer. So a critical issue in the real world, having nothing to do with all the actual equation information theory we study, is we've got to come up with a new framework for designing cellular RF illumination systems for suburbia that are acceptable to the neighbors. And what differentiates engineering from physics is discern physical principles. Engineers try to make things that work in the real live world, and part of working in the real live world is A, it has to be affordable, and B, for example, it has to withstand wind, rain, whatever. Well, let me suggest that an additional constraint for cellular or wireless illumination systems is it has to be acceptable to the neighbors, and the current concepts are not. So take an architect out to lunch. The stealth bomber was an interesting collaboration between aeronautical engineers who knew how to make things fly and electromagnetic people that knew what radar cross-section was. And the U.S. military forced the two together and put them in a locked room and said, you will design an airplane that both flies and has a near zero radar cross-section. What we need is a bunch of electromagnetic people locked up in a room with some architects that will come up with a way of illuminating suburbia with wireless signals such that it's acceptable to the neighbors. Okay. Next issue. We all love to do tests like you have down the hall of cognitive radios talking to each other, and those are wonderful tests. Nobody wants to do these tests. And the big controversy in TV white space is basically the cross-correlation, spatial cross-correlation of these three paths. So imagine the TV transmitter at the left side, and the cognitive radio at the rightmost side there. Cognitive radio is sitting there, it's listening to the TV station, and it's trying to transmit a low-power signal if the frequency is vacant. This has nothing to do with technology. This is basically propagation in the real world that has real terrain, real objects, real people, real movement. And one of the key problems that's blocking a lot of cognitive radio use is understanding the correlations between those three path losses. And I believe that nobody wants to do that because everybody wants to develop their own little hardware. But that a better understanding of these spatial correlations of propagation losses is key to many cognitive radio systems. But nobody wants to spend money on it because it's not dependent upon their hardware. And finally, the classic way to regulate interference for wireless systems is spectrum mass. That is, you go 100 kilohertz outside the band of your signal, it has to be down 20 dB. Another 100 kilohertz has to be down another 20 dB. That's charming, that works well. It's too restrictive in today's world. So, for example, the Europeans control intercellular system interference by concepts like ACLR, adjacent channel leakage ratio, where you, instead of a mask, you integrate the power, out-of-band power with the response of the receiver, and you talk about that type of limit. And I think we have to put on our thinking hat and look for alternatives to spectrum mass to control adjacent channel interference, because a lot of the problems with using today's spectrum, as spectrum gets more crowded, are complicated near-far ratios, where two people are a meter apart, and one using one frequency, and the other one's using a frequency nearby, and they could cause interference if you do the wrong thing. You could control that with channel mass, with spectrum mass, but it's too restrictive. It doesn't give the designer enough flexibility. It doesn't let the designer come up with alternative solutions to avoiding interference. So alternatives to spectrum mass are, I think, a key research issue in wireless policy. And finally, here's my website. It has lots of information besides pretty pictures of me, but I have a theory that the best way to get people to go to your website, and since I'm a consultant, I want people to go to my website, but you don't have to be you. You don't have to pay. You don't have to give me a consulting contract. So I put a lot of useful information on the website for both commercial customers and academics, in the hope that people go to the website and will think of me. So feel free to go over there and look at it. And I'd be glad to answer any questions you have.